Okay, now we're going to do part 4, which is finding the value of the acceleration due to gravity graphically. And we can do this using any of the equations of motion. So we've got the how fast equation, we've got the how far equation, and then the hybrid equation. So all three of these can be used to figure out what is the acceleration due to gravity. I'm going to demonstrate it for the how far equation. So that's going to be this one up here. You're going to do it for either the how fast equation or the hybrid equation. You get to choose which of the two equations to do. Now one of them, it's going to turn out, is a whole lot easier to do than the other one. But let me just demonstrate to you the principle behind it. Now, I don't want you to use the graphs that are provided for you by the simulation. I want you to actually plot points on Microsoft Excel and then make a graph and then find the slope of the graph and then use that to figure out the acceleration due to gravity. So that means that when we go back to our simulation here, I don't want you to use any of these graphs. So I'm going to go back to here and I'm going to click on World again, and then that gets rid of the graph. Now after you have completed it and you've figured out the acceleration due to gravity, if you want to go back and look at those other graphs and then see how close you got, it's okay to do that then, but not yet. Okay, now we're going to hit the reset button so that we want the ball up here. Okay, now we're going to go back to the lab, and the goal is to take this equation and turn it into an equation that's going to look like this: y equals mx plus b. So that's the equation for a straight line. So if you got, here's your graph, y is going to go up and down, x is going to go sideways, and the goal is to turn it into a straight line, and then the distance from here to here, that's going to be b. But it's going to turn out that your graph should go through 0, 0. And so then that would mean that it's going to go through this point here, which means that b is going to be 0. So we don't really even need to worry about that. So let's just concentrate on this graph right here. We're going to try to figure out the slope. Okay, now the problem, though, is look at our formula. It's obvious that r goes with y. Okay, now the slope is going to turn out to be g. And so that leaves us with our x is 1/2 t squared. Okay, so that's going to be this part here, and then we can put the g out in front. And then the goal is to make a graph that's going to be a straight line, and then the slope of that straight line is going to be g. Now the problem, though, is that we've got t squared. So you cannot graph distance versus time. It's not going to work. You'll get a curved graph if you do that. So what you need to graph is distance versus this part right here, 1/2 t squared. Okay, so I did that for you. So I went to the simulation, and then I did it by increments, so that I would click on skip forward here, and then I pick out 5 points that I want to graph. Now you can pick out any 5 points that you want to do, but what I did was I kind of broke this thing up, and I said, well, I'll put 1 here, and then I'll put 2 right about here, and then 3, and then 4 and 5. And so that's what I did. So remember that you can, by using the skip button, you can go down to any place that you want. It's going to tell you what the distance is. So the distance is over here, and it's also going to tell you what the speed is. So the speed is going to be here, and it's also going to tell you how much time has elapsed, so that you can write that number down as well. So you got this, the distance. For this one, we don't need the speed, because you see it depends on distance and time, so we don't even care about the speed one. So we're going to make a graph, and I went ahead and did it for you here. And so here's a graph of time that I got, and then these were the, now I had to take my t and square it. So with my calculator, I took 2.2 squared and then divide by 2, and then I get this number here. And then I took this number and I squared it, and then I divided by 2 and I got this number. So you needed to, or I did this one here. These numbers are generated using these numbers. And then I've got, here's the distances that the ball fell. So those were just pure numbers that I picked off of the graph. You can use different numbers if you want. Now we need to make a graph. Okay, do not make a time versus distance graph. We needed to make this graph right here. So the way that you do it is that you highlight the numbers. Do not get any units in there, otherwise it cannot graph. It has to be pure numbers. Okay, now we're going to insert. So we go up to here and we click on insert, and here's our graphs, and we want this one, the charts. So I click on that, and then we got all sorts of different kinds of graphs that you can make. And the one that we want is this one right here, because it gives you the data points and it gives you a smooth curve. Still don't want that, but that is our curve that we're getting. So let me go ahead and click on that. Now you got to put titles on it. So we're going to go over to here where it says add. Well, first we can just do the chart title. So click on this and then type in whatever descriptive title you want. What's the graph trying to show you? So go ahead and put the title in there, and then go over to here where it says add chart element. Okay, and you have axis titles, and you got the primary horizontal and you got the primary vertical. So you're going to click on those, and then you're going to put in what is the sideways part telling you and what is the up and down part telling you. So do not put in X and Y. So you're going to put in what does it represent. And the way to do this is to look at the numbers. So you see the numbers are going from 0 to 12. And then if we go back to our data, you can see what numbers are those that are going from 0 to 12. And then you got these numbers that are going from 0 up to 120. And then that's going to tell you what those things are representing. Okay, so let me get rid of this for the moment. So I'm going to cut this. And so here's the completed graph. Now you're going to make your own whenever you do it for one of the other two equations. So I'm just showing you that this is what mine looked like. Now that should be a straight line. Well, it's not quite a straight line. And that's because there's some error in the computer program. But it should have been a straight line, and it should have gone through 0, 0. So then the next thing is we're going to click on a data point. Okay, then we go down to here where it says add trend line. So you're going to click on add the trend line. Okay, and we do want a straight line, so this is a linear. So it's going to be this one here, linear. And if you want, you can click on exponential and logarithm just to see what happens. But it is supposed to be a straight line. So linear is fine. Going to click on that. And then down here, it says display the equation on the chart. So you're going to click on that. And then there is our equation, y equals mx plus b. And remember, ignore the b because it's supposed to be going through 0, 0. And the x is this part right here. And then the slope should be g. And if you look at that slope right there, you see it's 10.53. And what should it have been? 9.81. Well, 10 is pretty close to 9.81. So it's not bad, but it could have been better. Okay, so let me now go on down to here. So this is, again, this is the completed chart that has everything labeled, including the units. And then it has the, let me get rid of this. Okay, and then it has the trend line on there. And then it's got the equation of the straight line. And then the slope was this number, and it should have been that number. So the graphical answer is close. So now it's your turn. So I'm giving you, here's a blank chart that you can fill in. So you're going to pick either the how fast equation. So the how fast is going to be the one that says that the final velocity was equal to the initial velocity plus, now if it was going up and down, then it's g, t, and then because it was in your hand before you dropped it, then that means that this part isn't there. So there's your equation for the how fast. Or you could graph the hybrid. So the hybrid is going to be squared is going to be equal to, again, the initial velocity is 0, so you don't need to worry about it, but you do have that 2g and then r. So I'm going to let you choose, do you want to graph this one and then find the slope of it, or do you want to graph this one and then find the slope of it? Now I'm telling you, one of those two is easier to do than the other. So I'm not going to tell you which one it is, but you can go ahead and do that. So first you're going to have to make a data table, just like I did. Then you're going to have to make a graph, and then the graph goes here. Okay, then you're going to find the trend line, and you're going to find the slope of the trend line, and then you're going to put that slope here, and it should be a number close to 9.8 if you do it correctly. So that's it. So here's our post-lab questions. Write down what was the purpose of the lab. What was the source of error? So what do you think were some problems with the simulation that made it so it didn't exactly give you the right answer? So put that in there. Then what is the acceleration due to gravity? So that's a really easy one. So put that there. Okay, now I've already done this part. So if you recall, I talked about this. So I'm going to let you write your answer here. If you can't remember, then back me up and go to the part where I talked about the negative signs and why we don't need to bother with them. Okay, then question number 5. Why do you think the simulation dropped the ball from such a great height? So it dropped it from 103 meters. Why didn't they just drop it from a height of 1 meter? So I will let you try to come up with the answer to that. How many of you ever seen Lassie? So Lassie was an old television show, probably back in the 1950s, and it was before my time, but there was this kid named Timmy, and Timmy, I don't know if he wasn't all that bright, because he was always getting into problems, into trouble. And so in one episode, Timmy falls down a well. And Lassie, okay, Lassie was his dog, and Lassie was very intelligent, and so Lassie goes home and barks furiously until the parents follow the dog to the well and then fish Timmy out. So it has a happy ending to it. So Timmy has fallen into a well. You then take a rock and you drop it into the well, and you hear either a splash or you hear Timmy yelling because the rock hit him on the head. But anyway, you hear, let's just say it missed him, and you hear the splash of the water 2 seconds later. So you drop it, and then 2 seconds later you hear the sound of the splash. Use one of the vertical motion equations to calculate how deep the well was. So you're either going to use the what, how fast, how far, or the hybrid equation, and the goal is to figure out how deep the well is. So I'm not going to tell you which one to use, but go ahead and do that. Number 7 then says use one of the vertical motion equations to calculate how fast the rock was traveling when it hit the bottom of the well. So you're going to use a different equation to do question 7. Okay, then question number 8 is what would a rock falling on the surface of the moon look like compared to a rock falling on Earth, and explain why. And then question number 9, you may need to look this one up on the internet. Is the acceleration due to gravity really a constant? And if it's not a constant, explain why we refer to it as being a constant. Okay, so again, you might want to look that one up on the internet to find out the answer to it. And I believe that let's just make sure, yep. Okay, so that's it. So we're all done. And so until next time, I'll see you.